All right, so this is Pre-Cal 36.3. So in 6.3, we're proving identities. So this homework is asking you to do specific things in order to transform these expressions. So this one's asking you to factor and simplify each rational expression. So factoring is a huge part of breaking these things down, okay? So what you want to notice in question number 1 is that in the numerator, that's the top part of the fraction, we have a sine x as one term, and then the terms are separated by plus or minuses, right? So this is a second term, and we have a factor of sine x in the second term. You see, this is sine x times cos squared x. So what we're going to do for A is we're going to remove the common factor from each term, which is sine x. So sine x, make a bracket, what's left over? When I divide the first term by sine x, I get 1. I took out a positive sine x, so this minus stays a minus in there. And then if I have sine x times cos x squared, and I divide that by sine x, that's gone, and I'm left with just cos squared x. The bottom will stay sine squared x. Okay. All right. Good with that first step, the factoring there. You see the common factor? That's pretty basic recognition, pretty basic skill there. Sine x is a common factor. Okay. So now, factor and simplify. So this 1 minus cos squared x is an identity, right? Does anyone recognize this as an identity? So what does 1 minus cos squared x actually turn into? It does. So I have sine x times, this is now sine squared x. Very good. Over sine squared x. So this, using this as an identity, rewriting this is perfect. Now we can see that we can simplify by dividing out common factors. This is multiplied, so you can just eliminate one of them if it's a common factor from the bottom. And then this should be, I guess, just sine x, the simplification. Does that look good? Okay, any specific questions about that one?
Do you have to write the QED thing because you're not necessarily
No,
having...
you don't have to write QED. We're not, it's not a proof. Not necessarily, no. Good question, but no, don't worry about it. Okay, let's do, excuse me, let's do B together. Question B. So I'm gonna erase that now. If you're slow on copying that, I'm sorry, but be faster. Okay, so this is, there's 3 terms here, isn't there? 1, 2, 3. So that looks like it could be a quadratic form. All right, I'm just going to rewrite it here so I can kind of mess with it. Over 6 cos x minus 12. All right, so this is a quadratic form, and if you see that cos x, if we let cos x equal like w or something, like another variable, then this is w squared, right? And this is just w. So I'm just going to rewrite that for now. W squared minus w minus 2. This might help you, and this is 6w actually, minus 12 on the bottom. So that actually might help you see how to factor and simplify this. If it does, that's great. We just have to remember to substitute this back in when we're done. So this is going to become w, let's see, that's a quadratic. So what 2 numbers multiply to -2 and add to -1? -2 and plus 1, right? So those multiply to -2 and they add up to -1. Now I can take a 6 out down here, right? And I actually have 6 times w minus 2. At this point, you can feel free to say, hey, I have a common factor. And you can eliminate that right now. That's not a problem at all. Because whatever w is the same w up here. So w minus 2 on the top is the same as w minus 2 on the bottom. Even though it's cos x minus 2, it's still the same. So you can eliminate it right away. What I would suggest there now is that you have to resubstitute cos x back in for w to finalize this. So is there anything else we can do? Not really. So this is going to be cos x plus 1 over 6. And I think that should be your final answer for B. Does that look familiar to anyone that's, or can you check the back of the book for me and see what that says, the back? Looks good? Okay. Any questions about that one? Pretty good? Okay, the quadratics are tricky. You gotta pay close attention to the quadratics. Okay, so do C and D by yourself, please now. Do C, because it looks like it's just like A, for the most part, and D is just like C. So can you please do those ones on your own? I'll give you a few minutes to do those ones, and then we'll talk about it in a bit. So do C and D there right now, okay? And I don't know if it's part of your, yeah, no. D is not technically part of your assignment, but I would like you to do C and D just while we're working on that, okay? Okay, so there's letter C. So what I did there was took the sign out as a common factor. I was left with cos x minus 1. And the bottom, this is a difference of perfect squares, if you notice. So, yeah, cos squared x minus 1. Minus 1. Maybe, did anyone write this as negative sine squared x?
Oh, I did that what I did was, like, I took out sine, and then I turned the cos x negative 1 into negative sine, and then...
No, you can't turn cos x minus 1 into negative sine, because that's cos squared x minus 1.
Oh.
Yeah, you can't take off the squares on the cos. So like sine x plus cos x, that doesn't equal 1. It has to be squared. Now, because this is, so 1, like if it was squared, right, then that's true. So cos squared, how am I going to write this? So 1 minus cos squared x is equal to sine squared x. So that negative, if you multiply negative by both sides, which you could, that becomes cos squared x minus 1. So you could have rewritten this, I think, as negative sine squared on the bottom, but then you would have cos x minus 1 over sine. Did anyone have that? Cos x minus 1 over sine? I think that's what you would get. Anybody? No? What does the back of the book say? Is it this one?
Yeah.
It's that one? Okay. Okay, just for curiosity, if you guys are doing your homework like this and you choose to do a different method and it simplifies to something different, you can check to see if what you've done is right, because they could be equal. Those could be equal, just written in a different way, right? So what you want to do is go to Desmos or graphing technology and then graph each of these. Graph them, y equals, and see if they're the exact same graph. If they match up the exact same graph, then your answer is just as correct as the one that's in the back. Because sometimes there's slightly different forms, right? Slightly different. Okay, so it should be a negative down here. I forgot to write down. So if you got this, and the back of the book said this, graph them both, which I have over here on Desmos. Okay, if you graph them both, there they are. And then look at, they're the exact same graph. You see? They're the exact same graph. And you can zoom out and make sure that they match up everywhere. There you go. So that one answer is the same as the other answer. And that'll happen sometimes. Sometimes it's not obvious which is the most simplified or the proper simplification. Okay? Any questions about that? Okay, so this is probably the one that most of us got, I think. Okay, D, I didn't do D here yet. Let's do D. Okay, so D, here we have a quadratic. So now, again, if you want to substitute, go right ahead. You don't have to. I don't think you have to. This is like x squared minus 3x minus 4, right? So this is going to be tan x and tan x. Going to multiply to tan x squared. So two numbers that multiply to negative 4 and add to negative 3, that looks like it's going to be negative 4 plus 1, right? So if you don't do the substitution, you really don't have to. You might be able to just go straight to there. And then down here, we're probably going to factor a, looks like a sine x out. And what am I left with? I'm left with tan x plus 1. And then there. So this should be your final answer. Did you get that as your final answer right there?
The back of the book simplifies it, but I don't know
Oh,
how they get there.
the back of the book simplifies this? Wait, tan x minus 4?
They simplify it to secant x minus 4 cosecant x, and I don't know how they got the simplification.
Okay, wait, what? Oh,
Yeah.
okay, so, okay. Okay, all right. Simplify. Tan x is technically sine over cos, right? So, watch this. If this was rewritten as sine x over cos x minus 4, then we can, you see there's a sine here and there's a sine inside of tan. So really those should be reconciled. They should be, that should be simplified a bit more. So probably, you're right, the tan probably won't stick as a final simplification. So how do we do this? Well, you could flip and multiply the bottom fraction, right? You could do that, and then have to multiply by both. So what would that be? That would be sine x over cos x. If we flipped and multiplied, that's multiplying everything by 1 over sine, right? So if we did that, then this would be sine x on the bottom there as well, right? This would be 4 over sine x when I multiply this in. Everyone see that? So now we do have another level of simplification. So the sines are gone. 1 over cos x is secant x. And then this is minus 4 cosecant x. And is that what it says?
Mm-hmm.
Yes, okay. So that doesn't have any entanglements there with the sine being in the tan and being a sine. So now again, factor and simplify. It is a little tough. How far do you go, right? So if there's any sines or tans or coses that can be divided out, you should try and get at those to simplify some more. So that's as simple as you can get. Okay? Good for number 1?